Okay, so when we look at our LED, the segments are identified by letters, and those letters correspond to different ports on the basis board, and the mapping, well, here we have the mapping CA, CB, CC, CD, and so forth. If you actually look at your constraints file, that's not what they're called. They are called like U7. Those are LEDs. Sorry, hold on. So W6, U8, V8, U5, and so if the template file had CA, CB, and so forth in them, then those would be good ones to use. But the template file already has seg in them, and so I like using those because it's already done and saves me time. And now it's not going back to OneNote. There we go. So what you want to do is think about your 7 segments, 1, 2, 3, 4, 5, 6, 7, and it's starting with A, B, C, D, E, F, G, and I actually do 8. I do 8, and I put, it's not H, this is the decimal point right there. And whichever ones you want to be lit up should have a 0, and whichever ones you don't want to be lit up should have a 1. So let's say I wanted the number 5. So if I wanted 5, then I want A to be lit up, I want F to be lit up, I want G to be lit up, I want C to be lit up, and I want D to be lit up. And it's easy enough for me to remember where these are, A, B, C, D, E, F, and then G goes across the middle. So that's, the first bit starts going across and then goes around in the middle, and the decimal point is the last one. And anything that I don't want lit up, I'll put a 1 in here. So then what I can do is I can take whatever variable that I have assigned to be for that particular purpose. So I have here, it looks like I used seg, and oh, I do not like it being from 6 to 0. I don't like that one bit. I would prefer to have 0:6 because A is 0. So I would have, this is how I would do it, because otherwise I'd have to turn my vector, my number around backwards. So 0:6, and then that I'm calling it segment. You could call it C, and then I would say C equals 7 apostrophe binary, and then 0100 0100 00. And if I had that mapped in my template, if I had C mapped to the 7 segment display, that would tell it which segments to light up, and then my AN signal would tell it which of my 4 displays to use. Okay, so I have oh, okay, well, I did mess up. Yep. No, I mean, so good. Because I thought I had, let me look at the constraints real quick. Let's see. So we have, I just want to make sure that I'm telling you all right. Okay. CA is W7. And now we'll look at the constraint file. Yeah, W7. Okay, so W7 is A. So in the constraints file, 0 is A, seg 0 is A, seg 1 is B, seg 2 is D, seg 3. Okay, so in the constraints file as written, these go in order A, B, C, D, E, F, G, decimal point. So what I would want on mine, if I'm using this constraints file, then I would actually not want what I have here. So I have seg going from 7 to 0. I would prefer seg to go from 0 to 7 because when I made this, I meant for this parameter to correspond to the 7, and that's why I gave it that name. But I had a strong suspicion, since I'm making mistakes, I'd probably make a mistake, and then y'all would be left to figure out what it actually is. And good, I did make a mistake, and you will have to figure out what it actually is. So let's start with I don't know, reg is like really not a variable name. I don't know what I was thinking. Output reg, this should be AN. So reg is something else that I will tell you what that is in a minute. So so what I meant to say here is output reg, you do need the reg there, and I'll explain that in a minute. Output reg 03 AN, that's how AN is defined. And then later on, I have AN equals 4 B0111. Okay, so which display is selected?
Display 0 is selected.
Don't all speak at once.
Or for set low, I guess, would be.
Display 0 is selected.
It actually is display. It seems like. Oh, so.
Prefer set low, I guess.
Okay, so. What? Okay. Did I have this one backwards too? Let me see. I think you are right. You are right, because I think in his instructions he has it the other way around. So I think you are right. So hold on. When I wrote the Verilog that I copied these from last year, I think it has changed a little bit. I think he originally had them in the opposite order, and then that made them backwards. So this is going 3 to 0. Nope. 3. And was I going 0 to 3? Yep. So yes, you are right. So I was going 0 to 3, and he was going from it. Yes, it does correspond to. So this one is in the 0th position, and that does correspond to display 0. And so the one that is active low, that is the one that is on, right? And so if I had done instead, find it as 30 AN, and I had it like this, and I had 0111, then that would be display 3 that was turned on. Now I want you to try to figure out if I make 7 equal to this 8-bit number, which is 0001111, no, 3 zeros and 5 ones, and I honestly don't know the answer now. And I have made segment. Oh no, I do know the answer because I have it backwards. Let's say I had the segment. No, I don't know. I still have it 7 colon 0. Okay, so I have 7 0. I want to know what is actually lit up on this one. So I have and this is A, B, C, D, E, F, G, and the decimal point is H. And these correspond to 0,
It's gonna be the dot, G, and
1,
F, right?
2, 3, 4, 5, 6, 7. Okay, so what is this going to look like if this is how I have things set up?
It's gonna be the dot, G, and F.
It is going to be the dot, yes, and G and F. Yep. And that would be the opposite of how it would be if I went from 0 to 7. Well, not the opposite. If I went from 0 to 7, then I would have lit up 0, 1, and 2, which is what I thought I was doing when I wrote it. It's the reason it's backwards is, like, I think last year we had some code that was in one direction and some code that was in the other, but I think he's got it all cleaned up now, and his code is all correct. It's my old code that is backwards. So, okay. Questions on this 7-segment display before we get on to the case statement? All right, so the case statement, what the case statement does is it allows you to do, I forget, y'all have had C++, so it's like a case statement in other computer programming languages, and it allows you to have a multiple number of ifs all at the same time based on your input. So I could have, like I have here in my Verilog, so this was some code I wrote last year. It is very similar to what you're going to do. It's not exactly correct. Actually, let me go not here, but to my OneNote. Okay, so I purposefully did not fill in, the correct things here, because you will have to fill this in, and you also do not have to do it this way. I did 2 case statements. You can do 2 always blocks. I'll talk about always blocks in a minute. So the way I have this set up is based on the values of x and y. It will give a different value for AN or a different value for seg. And so it'll look at x, and x is a 2-bit number, and it'll look at what that is. X you're going to have mapped to 2 switches. And so those 2 switches, what you'll have whether they're on or not, will tell you what value you have for x. So in your lab instructions, it says, when you actually get to that part, depending on what group you are in. So you will have 2 vector inputs, x and y, each with 2 bits. Each of these is going to be mapped to a switch, and that switch is going to tell you what display to display, and then the other switch will tell you what is going to be on that display. So let's say you are in the group on the left. If your 2 switches are both off, then you would just select display 0. If both switches are on, you would just select display 3. And then depending on the 2 switches mapped to Y, that would be what what you should show, what that LED should show. So you're going to have to come up with what the signals are that would make the shape L and the shape S and the shape U, and put those in. So you can see that an easy way to do that is with the case statement. And he suggests in his instructions that you might use two always blocks. When I did it, I am bad about like not reading everything, and I did two case statements instead of two always blocks, and it seemed to work fine. So the way a case statement is here, I did mine just very straight up. You know, it's 0, 0, 0, 1. And so what that would mean for X, that would mean like for the 2B00, so 2B00, that would be that X0 equals 0 and X1 equals 0, or that both of my switches were off. If I had 1, 0, I don't know how I had these assigned. It would depend on how I had these assigned. So like in your constraints, so in my constraints, I had X0 assigned to pin V17 and X1 assigned to pin V16, and I had, the way I had it, I had 1, 0. Okay, all right, so I don't remember where in here the, yeah. So looks like 16 and 17 are the two at the end. So I assigned them to the two at the end, and I don't remember which one I made 0 and which one I made 1, but I made one of them 0 and one of them 1. So you're going to have to figure that out on your own, what you want to do with that. And then based on that, and based on what your instructions are, then you will have, like, because your instructions will tell you whatever X is and whatever X1 and X0 are, which display you're going to have activated. So that's what that one case statement is for. And then the other case statement is going to tell you what segments you're going to light up. So you'll have that. And so your code is actually going to be very short. There's not a whole lot of code for this. And so going back to the case statement, just telling you how the case statement works. And you'll find that there are times when you'll want to do different things with it. So notice in this example right here, you have an input W that is 2 bits wide, and you have an input enable that is just 1 bit wide. But on your case statement, you're putting them all together. And so you're treating it as one signal, and so you can definitely do that. So like this first one, like this case right here, that is saying that EN is 1 and W1 is 0 and W0 is also 0. So you have the 3 bits here, and those 3 bits are telling you, what you're looking for in all 3 of these variables. So you can definitely put, 2 variables together like that to increase your possibilities here. So if I had really wanted to, I could have combined my case statement, and I could have put X and Y together and made a case x, y, but that would actually not be very efficient because that would give me 2 to the 4, or that would give me 16 different values I'd have to come up with, and then I have some nested stuff, so it really would not be efficient in this instance to do it that way because the x and the y really are defining separate different things, so better to put them in different blocks. So this is one way to do it. Another way to do it is you can actually put in what the decimal value of that of those binary numbers, and you can do that. Now notice on this one we have 3 bits, which means we have a total of 8 different possibilities. And so the case statement, you have to have something for everything. And so since I've only identified 4 things, I have to have this line for default. I recommend you always put a default in. Even if you think you have everything defined, go ahead and put a default in. So you'll have your case, you'll have what you're checking, you'll have your different possibilities, and then the default, and then end case. Okay. All right, now let's talk about an always block. Okay, questions about the case statement before I do the always block? Okay, so the always block, what the always block does is it is checking its sensitivity list. The sensitivity list is what comes in parentheses after the @ symbol. And anytime anything in that sensitivity list changes, then it will do whatever is in the always block. Now, there's 2 types of assignments that you can do. One thing you should be aware of, that if you are assigning a value to something inside an always block, you have to define that value as a register or reg. So here in this example, LEDs is being assigned inside the always block, and so when it is declared up here, it's declared as reg. And so anytime you do that, you have to have reg. Now, you will often want to use what's called the non-blocking assignment, and the non-blocking assignment looks like this right here. So it has the less than sign and the equals. What that is used for, because you're going to be doing a lot of sequential programming, I don't think it would matter in this particular example, but when you get to the always block, so imagine you've got several flip-flops in a row. So I've got this flip-flop and this flip-flop, and I'm going back over here and I'm doing this. When this value changes, so the value on this wire changes, well, that can change what this one is doing, but I want it to do everything all at once at whatever the clock signal is. So I don't want it to make a change in a variable, and like if I had A equals, if I change A to 3 right here, and then later on I have B equals A plus 1, I want it to use whatever value A had when I got into the always block. So whenever you're doing something that is based on the system clock that you want it to do at a clock signal, you're going to want to use this non-blocking assignment. And the non-blocking assignment, it basically freezes everything at the state it was when you get to the always block, and it uses the old values rather than some updated value. And this is going to be especially important when you are you have things that are being done sequentially. I think in this lab it doesn't really matter, but that's what this non-blocking assignment is. And okay, so I think I've done everything except the test bench, and I will do the test bench next, unless there are any questions on anything before I get to the test bench. All right, I'm going to stop this, and save it, and then I will do the test bench.